the lesson for Chapter 6, Section 4, Applications of Linear Systems, the first day. So let's take a look at our first type of problem we'll see, and we're dealing with business situations. Here we're dealing with an expense and an income equation. And notice what expense and income equations look like. Whenever we're looking at expenses, the expenses are going to continue to go up as the number of items increase. So sometimes people think an expense line, expense means like a decreasing line. You're spending money, you're decreasing the line. Well, here we're spending money, but the line is increasing because of the units we're using. The dollars increase as the number of items increase. So both are increasing lines. Our income is going to increase as number of items increase, and our expenses are going to also increase. But what we're going to be looking for is this break-even point. And so we're looking for a point where the two lines cross, and that's going to be our break-even point. And so what that will represent is, at first, the expenses are higher. You can see the red line's expenses. That's a higher line, so the dollars are greater than they are on the income side, the side that you're making money. But eventually, if we price things right, our income will increase and a little quicker than the expenses will, which will allow our income to go past the expenses. And at that point is the point in which you end up starting to make money afterwards. And so that's what the yellow shaded area represents. Is anything to the right of those items made makes you making more money than you are spending. So let's take a look at a problem here. It says a fashion designer makes and sells hats, and the material for each hat costs $5.50. The hat sells for $12.50 each, and the designer spends a total of $1,400 on advertising. Okay, so what we want to do is we want to write two equations. We want to write an income equation and an expense equation. But the first thing I need to do is set up some variables. And so what we're asking for is, one thing we don't know is the number of hats. And so I'm going to use H as the number of hats. And then I'm going to use, we don't know the amount of money that we'll end up making. So let's do that. So Y equals maybe the amount of money. And so now we're going to set up our two equations. Remember I said we had an income equation. So that's going to end up being the blue line here. Hopefully it's a little steeper slope. And then we're going to have an expense equation. And so let's set up our two equations. First one, we're going to say income is Y equals, the amount of money equals $12.50 for every hat we sell. So that's our income. That's what we're selling the hats for. And so we sell the hats for that amount. We're going to make that money when we go ahead and sell the hats, but there's some that we're going to have to take away for our expenses. So the expenses side is going to be Y equals the amount of money we end up spending, in this case, $5.50 per hat. That's what it says right here. $5.50 is the cost, the material cost of each hat. And so plus, then we also have that $1,400 we're spending on advertising. So that's going to be a positive number because we're spending that. That's a dollars amount in here. And if we were at negative, that means that we'd end up actually not having that money to spend. So that'd be debt. And so we are spending that money, and that's where it's at. So what we do from here is we want to find out what is the break-even point. So I want to find out where the two lines cross. So I can use substitution. I can take that $12.50 and substitute it in for Y in the other equation. So I'm going to have $12.50H equals $5.50H plus $1,400. And so from that point, I'll subtract that $5.50 from both sides. And then I'm left with $7, and that's even. $7 H equals $1,400. So when I divide by 7, it goes in there evenly. It goes in H equals 200 times. So I have to sell 200 hats before I start making any money. Once I sell more than that, then I've started to make money. So we'll say that. So we wanted to find out what that amount would be. We'd do $12.50 times by the 200 hats that we'd end up spending, and that would make $2,500 is how much we're going to end up having to, at that point, that dollar amount is where our income and expenses will be the same. So what they're asking for is how many hats we must sell. So we'll say that the number of hats is 200 hats must be sold to break even. So let's take a look at our next problem. And it says a puzzle expert wrote a new Sudoku puzzle, and the initial cost are $864. Binding and packaging also costs 80 cents. Okay, so those are expenses. So let's write those expenses down. So we've got our expense equation set up first, and so we'll define some variables real quick. So we'll say maybe x equals the number of books of puzzle books, and we'll say y equals the dollar amount. And so our expense side would be this. Our dollar amount is going to end up being 80 cents per book, 80 cents times the number of books, x, and then also the initial cost, the $864. So that's the expense side. The income side is going to be how much we're going to sell the books for. It looks like we are selling the books for $2. So $2 times x. And so now we can go ahead and solve. It's the same type as before. We can just use the substitution method. So 2x equals 0.8x plus 864. And so I'll subtract that 0.8 from both sides. And so that leaves me with 1.2x equals 864. So I'll divide by the 0.12, or 1.2. And that leaves me with x equals 720 books. And so that's what our value is. In order to break even at this point, in which our expenses and income will be the same, we're going to end up having to sell 720 books. To find out how much money that would be, I would just double that, because I'll put it into my income equation. 2 times x, 720, and that makes 1440. So I have to sell 1,440 books, or that many. Well, I'd sell 720 books to make that amount of money. 1,440 is when I'll end up breaking even. So we'll say 720 books must be sold to break even. Well, let's look at the next type of problem that we'll end up seeing on the homework, and that is this. It says the local zoo is filling 2 water tanks for elephant exhibit. One tank contains 50 gallons and is filled at a constant rate of 10 gallons per hour. So whenever we see that word constant rate, that tells us we're dealing with the slope. And 50 gallons, that's what it already contains, so this is the initial amount, the beginning amount. The beginning, so this is where it starts. And that's why they end up using that symbol, or the letter B, for beginning, or for the y-intercept, because when we end up looking at that y-slope-intercept form, the y equals mx plus b, this is the beginning value, the initial value, where m represents our slope. And so we can write the equation that way. I'm going to go ahead and define the variables this way. I'll say y equals the total amount of gallons, number of gallons of water in the tank, and x equals, we'll say, the number of hours. And I get those units because I look at the slope. I look at the constant rate of change. Gallons is the y value, hours is the x value. And so I know that slope is the rise over the run, the change of y over change of x. So y is gallons, x is hours. So let's take a look at our first tank again. Tank number 1, it's going to be y equals, and then I've got that initial 50 gallons plus 10 gallons per hour. 8x is number of hours. So that's tank 1. Tank 2. Tank 2 is y equals, and then it says the second tank has 29 gallons, so 29 plus 3 gallons per hour. Now, as soon as I look at that, they're asking, when will the tanks have the same amount of water? Well, when I look at it, the 10-gallon, the one that's filling at 10 gallons an hour, already has more. It's filling at a faster rate. This one here has less, and it's filling at a slower rate. It will never catch up to this value. And so let's see what happens if I did go ahead and solve. So I'll go ahead and substitute in, and I have this, 3x plus 27 equals 10x plus 50. And so when I go ahead and solve, I'll subtract the 27 from all sides, and I'll subtract the 10x from all sides. And here's what happens. So I end up with negative 7x, and that's fine as long as this next number is negative, but it's not. And so let's see here, this is supposed to be 29, not 27, so let me fix that real quick. 29, 29. That makes a number that goes into. So this is our 50 here. So this makes 21. And see, that's not a negative number, so they're not going to cancel out. X is going to be negative 3. And that doesn't make sense. This doesn't make sense. Because I can't have negative time. And so negative time is one of those things when you end up getting that, x is hours, you can't have negative 3 hours. That makes no sense to us. And so that means that we've got a problem with the situation. So our problem is this, is that the second tank, or tank 2, the second tank, fills at a slower rate and has less to start with. So it will not have the same amount as tank 1. So that's the explanation there. Let's take a look at our next problem, and it says a jeweler, a metal alloy is a metal made of blending 2 or more types of metals. That's what the metal alloy is. And a jeweler has supplies of 2 metal alloys. One alloy is 30% gold, and another is 10% gold. How much of each alloy should the jeweler combine to create a 4 kilograms of an alloy containing 15% gold? Alright, so let's come up with our different unknowns. We need to mix these two different types. So let's go ahead and label it maybe like x equals the number of kilograms of the 30% gold, and we'll say maybe y equals the number of kilograms of 10% gold. Alright, so now we've got our variables defined. We can set up an equation. We've got a quantity equation here. Number of kilograms of the 30%, number of kilograms of the 10% needs to be 4 kilograms. So that's what they combine to make. Now the next one's going to be parts. This is going to be the percentage of gold. So it's going to be, we have a 30% for x, so 0.3 times x, and then 10% for the y, so 0.1 y equals, now we want one that is 15% gold. That's what we want the 4 kilograms to be. So we need to do 0.15 times by the 4 kilograms. So now we're ready to go. So what we'll do is I'm going to rewrite this bottom equation here, and I'm going to rewrite that as 0.3 x plus 0.1 y equals, and then when I multiply 0.15 times 4, I end up getting 0.6, 6/10. And so I'm going to multiply this top equation by, I'm going to cancel out the y's, it's easier, by negative 0.1, so each of the terms there. So I'll rewrite it down below. I've got negative 0.1x minus 0.1y equals negative 0.4. So when I add these together, I get the y's to cancel. I got 0.2x equals 0.2. So when I divide, x is going to end up being 1. So what does that represent? Well, I wrote it up here. Number of kilograms of the 30%. So 1 kilogram of 30% gold is what's needed. And I find the other one. Well, remember, x plus y equals 4. So 1 plus y equals 4. That would tell us y is 3. Well, what's y? Y right here, number of kilograms of the 10%. So 3 kilograms of the 10% gold. So that's what we end up seeing on the assignment today. So the big item I would end up recommending is to find the variables. It makes it a lot easier because once you solve, you'll forget about what is x and what is y, and then you got to go back into the equation to figure it out. If you just spend the time on writing down your variables now, defining your variables, it makes it a lot easier at the end of the problem. So those are the types of problems you're going to see on tonight's homework. Good luck.